Now this file is actually not that long. It's a JSON file, JSON format. And first of all, we have the index page. This indicates what is the root page of our app we want to cache and load. And that, of course, is the index.html file sitting directly in the root server folder we're serving from. And then we get a so-called asset group, or actually asset groups. It's an array. And in there, we got two asset groups, these objects which we have in there. Now, asset groups are configurations that define which static assets should be cached and how they should be cached. Dynamic assets, for example, would be the data from the API. So data we're fetching, which might change on that API. So it's not static, it changes frequently. Our HTML file, our JavaScript code will also change with every build, but after the build, it's static. It's not changing in some database or anything like that. So that's what an asset group is. We can give such a group a name, whichever name you like. And you can then define how should these assets be loaded. Prefetch means that when your page loads, Angular will go ahead, or the service worker will go ahead, and already prefetch all the assets which are specified in this asset group, which means it puts it into cache even if you haven't needed them yet. The alternative to prefetch is lazy. You can use that too, and that would only load them once you needed them at least once. The advantage of lazy is, of course, that you don't occupy all the bandwidth right at the beginning. The downside is that if you need it for the first time, it will not be there. So if the user loses the internet connection before the asset, let's say the CSS file, is required the first time, it will not work because it will not be cached. With prefetch, it will be cached even before you need it. There also is an update mode. I guess you can see it down there. Now, this is important for the case that you're pushing a new version of your Angular app and therefore also of your service worker to your server. And the user is already browsing on that server. And it will get informed about the new service worker. And now the service worker can already prefetch the updated assets or also load them lazily when they are required. Now, the assets which should be loaded are the resources then. Resources has one key property, the files, and there you have an array pointing to the files you want to cache. You can point at something like the index.html file, and this is always seen relative from the dist folder, so from the folder you will have in the end once you deploy this. But you can also set up patterns like every CSS file or every JavaScript file in the root folder. Or you could say every CSS file in any subfolder. This is what this pattern would say. So you can also set up glob patterns like this or directly point at the file you want to use. Without the hash, because you can't know the hash in advance, Angular will generate that automatically, will take the unhashed file names here, and then automatically generate a service worker which will take the hashes into account. Now here we get a second asset group for, well, basically all images we got and so on. It differs from the first one in regarding the fact that it's only preloading that if we need them, if we visited them or used them at least once. And this is leading to the behavior we have right now. Now we got one other static asset which is not included here. And that is our external font. It's not changing, or at least not regularly, so we can treat it as static. But it's not included here because it's not one of our files. But we can take it from the index.html file by just copying that entire link, which will be requested eventually. And then we can go back to the ngsw-config file, and there we tell Angular that we also want to cache this. Now we don't add it to files because this is for local files. There is an additional resource type we can define, and that is URLs. It's also an array of strings, but here we put URLs like this one, which are reaching out to our servers to then fetch resources from there. With that added, let's save that file, quit your server down there, and let's go back into our root project folder, and let's create another build with ng-build prod, like this. And once this is done, and we revisit the dist folder and serve that again, we should see that the font is also loaded in an offline mode. So we go into the dist folder, into Angular PWA, rerun that HTTP server command, and let's reload that page. And with it reloaded, and you might also close it and open a new tab to ensure that the new service worker gets really loaded and it's not still using an old one. With that loaded, you can tick that offline box here again, Or since I always needed to do that, simply turn the Wi-Fi off. Go to the network tab to see all requests and reload the page. And now you should see that the font here also is not marked as red, but is actually loading the font as it should. So this is now also working. It's now also fetching this, and we're still, or now again, able to use it in offline mode, that font. Now what about the API? Regarding the API, we can also prefetch this. For that, we add a new configuration item, and that would be data groups. Remember, we got asset groups here for the static files essentially. Data groups is for dynamic data. So typically data you request from an API, data that might change frequently. How is a data group configured? It is an array because it's data groups here, but one data group is then again an object, just as an asset group. You then define a name of your choice, like posts, but that name is totally up to you. And then you define the URLs you want to handle with this group. And in my case, that is the URL I can see in my app component, which is where I make this HTTP request. This URL to JSON placeholder. This is what I'll take, and this is what I'll put into the URLs array as a string. You could now also add a version here. If you got an API which might have different versions and the version changed, then you could lock the version in here to, for example, cache different data pieces side by side for different API versions. Here I will not use the version. And instead, what you can add here is a cache config. This is another object where you can now in detail configure how this data should be cached. And for that, you can, for example, set a max size. This is a number, and this defines how many entries do you want to cache. And now that's important. This does not mean how many posts, for example. This means how many responses. Now for this single URL, we will only cache one response at a time. But if you had a more generic URL with a star, let's say, for different endpoints, then you might want to make sure that only for 10 outgoing requests, the answer was cached, to not pollute your cache and grow it infinitely, because your space is actually limited and managed by the browser, so you don't want to cache everything. So here we could say cache 5 responses. Again, for this example, it doesn't matter. We can then also add max age to define how old should the data in the cache be before we get rid of it and definitely fetch new data. Because you might want to fetch from cache first, to deliver something onto the screen as quick as possible, and then maybe reach out to more up-to-date data behind the scenes. But for that, you of course need to know, is the data in the cache still valid, or should I always fetch new data? This is defined as a string, which you write like this. You could say 1 day, or 12 hours, or 50 minutes. This is essentially the format you have. Details can be found in the official docs, and you find a link to that attached to this video too. So here I'll go with, let's say, 6 hours. And then you can also add a timeout. The timeout is defined in the same way. And there you could say, if I'm waiting for a response for, let's say, 10 seconds already, then I want to fall back to the cache and not wait longer, but I don't want to use the cache immediately. I want to wait for these 10 seconds at least. So I could say 10 seconds here. Last but not least, and that's important because it works together with the above values, the strategy. There you can have 2 types of strategy. Freshness, which means always try to reach out to the backend first and only use the cache if you're offline. Or performance. Performance tries to get something onto the screen as quick as possible, and it will take max age into account to know whether it should absolutely reach out to the backend or just use the cache value. On the other hand, freshness will take timeout into account to know how long to wait for a response before it uses the cache. So I will go with freshness here, and I will save this. And now you know the game. Let's go back and let's build this again with --prod. And what we should see is that now that we built this, that if we then go back to the build project and serve it, that this actually then works in offline mode. So let's bring up that HTTP server, reload this page, and as I mentioned before, feel free to close it because a new service worker to be registered should also be able to be loaded without you closing that tab and opening a new one. Angular can handle that, but by default, this is required. By default, for a new service worker to go active or to turn active and do its job, you need to reload the page. Also, because Angular does not use the new updated code you might ship onto the server and load it into your already running app, because that might break your already running app. So close the tab, open a new one. Now in that new tab, reload at least once so that the API responses can be cached. The first reload loads the service worker, the second one loads the API responses, then turn off the Wi-Fi and load again. And what you should see is that you still got your posts here. Now one thing you can notice is that the fonts are missing because, and that's just something you have to know about Google Fonts, the way it's loaded, it takes two URLs. This is the URL where it goes to and tries to fetch the font then. The other URL we put in there is the one which just holds the rules for the font, and then that extra URL. So let's add that newly gathered information here. Now replace this at the end here with ** to load any fonts from the URL. Close the HTTP server and build this one more time as you saw it before with ng-build --prod. And we could already see that the API data was loaded at least, so that this was present. Now with this build one more time, let's again go back to our dist folder and let's serve this one more time. But then open a new tab for it to become active. Reload this one more time to store, to make sure that the responses are really stored, I should say. And now let's go offline again and reload this app. And you see the fonts are there too. And in the network tab, we see everything is fetched. The posts fail, but that's no problem because we take that from the cache, which works. You can see it here in the response. There it is. And this is how we can use the service worker, the Angular service worker package, which you can easily add with the ng-add @Angular PWA package, which includes that service worker package, which also gives you that manifest.json file, and which overall is something you have to learn, but then gives you the powerful tool of making your web app offline available. Now check the official docs, which you find attached to the video, of course, and I hope that this was helpful.